Hi, in this last lesson, I thought it would be interesting to take a first look at Houdini's new LOPS context, together with the Karma renderer. Karma is still in beta stage as I'm recording this course, but it will eventually supplant Mantra, so it's a good idea to start getting familiar with it. The idea with LOPS, or lighting operators, is that it's a place or context where you can build, import, and manipulate USD scenes. USD is Pixar's universal scene description standard. I won't go into too much depth on the intricacies of USD here, because there's a lot of it, but it's worth knowing that it's what LOPS is all about. I think that a good way into learning LOPS and Karma would be to take some of the assets we've been working with so far and see how far we can get with rendering them via LOPS. So let's start by creating a LOP network under /obj. And we'll dive inside. So we're inside the LOPnet, and now we can start importing assets from the rest of Houdini. So the first thing I'll do is tab down a scene import node. Now we can use one of these to just slurp in everything that's in OBJ, but I think it's probably a better idea just to be a little bit more selective. So we'll choose render ground, and we have the ground in there. Then I think we should duplicate this. So I'll just Alt drag to duplicate it, and for this one, we'll grab our RBDs. Okay, and then we can merge these together. Next, let's add a camera. So we'll just tab down a camera. Now, it is possible to import cameras from the rest of Houdini, but I haven't actually been incredibly successful with doing that. So we're just going to create a native LOPS camera. And then I'm going to grab the transforms from the camera we have in /obj. So I'll copy the translate, and I'll just paste the values, and I will do the same with the rotate, and paste those. And then I think everything else is pretty straightforward. The focal length of the camera is 50. We'll just change the view. We'll set this to 0.001 and this to 100. And we can see that Karma is actually rendering inside the viewport, which is one of the cool things about LOPS. We get this really nice path trace view right inside the viewport. Okay, let's add a light. We'll add a dome light, which is the closest thing to the environment light that we're using outside in /obj. The next thing we'll do is we'll grab the HDRI that we've been using, and we'll plug that into our dome light. I just select our environment light, go to the light, and I'll just double click and grab this. And in here, we can just plug that straight in there. It'll take a second to load it, and then we should get a render. We just need to set the exposure to match our environment light. One thing I've noticed is that the camera field of view is a little bit different. It seems like the camera math works differently. So to get it to line up with the camera in /obj, we just need to set it to half the focal length. I think it's calculating the aperture differently. Okay, so now that we have some scene geometry and a camera and a light, the next thing to do is to put down an actual Karma node, which we can do there. And I'm just going to switch this back to Houdini gel. Now the karma is already pointing at our camera. And we can kick off a render to mplay like this. I'm going to escape this because it'll take a little while to converge, but it's producing a pretty nice render pretty quickly, which is great. The next thing we're going to want to do is to assign some shaders to our geometry, specifically our chunks of rubble. I'm just going to rename this to scene import rubble. Oh, I'm sorry, this one's ground. And this one to scene import rubble. Now in these scene import nodes, there's a section called materials. And this means that it's already importing materials that are assigned to the objects. So all we need to do is assign the materials that we already have. I'm going to do this by dropping down a material linker, and I'll just drop that onto the wire there. And we can see that these are the shaders we already created and we assigned to the rubble objects in SOPs. Now these don't come pre-assigned in LOPs. I'm sure there's a nice way of doing it, but I'm not quite sure what that is yet. However, we can simply drag these on and okay, those are now assigned. I took the liberty of altering the name attribute on the pieces of rubble so that they have the number for their particular material, which made it easy to identify them. So now that those are assigned, let's do another karma render and see what we get. It'll take a little bit longer this time because it's got to do the displacement and prep the geometry for rendering. Okay, and there it goes. Looks like we missed one of the objects, so we can go back and fill that in later. That's probably good enough. I'm not going to let this fully converge right now. Next, I'm going to import the dust from /obj. So I'll put down another scene import. I'll call this scene import dust. And I'll grab our render dust node. And there's the dust. So as you can see, the Karma viewport takes a little bit longer to update when it has to ray march through the dust. So it's probably not so useful with dust in the scene. So I'll just switch that back to Houdini Jail. Okay, for rendering the dust, I'm going to reduce the pixel samples a little bit. You'll notice that compared to Mantra's 2x2 or 3x3 and 6x6, this just has one number. So I'm going to lower this to 32 and we'll see what that looks like. I disabled the materials on the rocks just for speed. I think this is somewhere where we can probably improve the performance by changing the volume step rate, which is down here. So I'm going to set this the same as we had it in Mantra to 0.06 and see what that does to our dust render. So I'll just escape this by hitting escape there and I'll press render again. One of the aspects of rendering geometry for effects that I've really focused on in this course has been motion blur, and I don't think that even a brief coverage of LOPs and Karma would be complete if we didn't cover how to produce high quality motion blur in Karma. In order to focus on motion blur, I'm just going to disable dust. And if we look through the settings we have here, it looks like motion blur should be working. So I'll just go back to Karma in the viewport. And although we're getting a nice render, we don't appear to have any motion blur. We've got transform time samples set to 5. We've got geometry time samples set to 5. So we should have some motion blur. And just to verify, I'll render this to endplay. So yeah, everything's looking pretty crisp. And it turns out that there's a trick to producing motion blur in Karma. What you need to do is drop down a cache node. So we'll just pop this in underneath our scene import and we'll set this to cache rolling window frames. And what this does is it will cache, if we set before to 1, it'll cache 1 frame before, it'll cache 1 frame after, and then it will cache as many subsamples as we have in the last field. So by default this is 1, so it will just cache 1 frame forwards and 1 frame back. But if we set this to 0.125 to match the number of subframes we generated for the rubble, then that should work. We also need to make sure that where we're importing the rubble, we have our substep set to the correct number, and it is set to 8 here. And that looks better. It looks like we have some motion blur. If we step to a frame where there's a little bit more going on, and I cancel our end play render, then we see that we do indeed have full motion blur. What else can we do with lops and karma? Well, one thing that's pretty cool is the control over cameras and lenses that we have. So if we go to sampling on the camera, we can change our f-stop from 0, which is the default, and implies no depth of field blur. We can set that to a kind of real world f-stop, say 1.8, and we'll automatically get depth of field blur in the viewport, which is pretty cool. I'll set the focus distance to 0.85, which is about the center of this group of rocks. And just step a little bit further forwards to where we have some more rocks in the scene. And if I drop that to 1, you can see that we get a stronger effect. Now there are various other camera effects that we can produce really easily. I'm going to drop down a matte net just inside lops, and I'll jump inside there and I'll create a physical lens shader. So this simulates a real world lens, and we can apply this to our camera and get behavior that's very similar to a real camera. So if we go into Karma, we can switch this from do nothing to set or create and check use lens shader, and then go to set or create, and then we'll just pick the lens shader we created. The lens shader gives us control over things like the shape of the aperture for generating bokeh. It's kind of hard to see in a scene like this, but if we had very bright highlights, it would be much more obvious. And what's really cool is that we can produce lens distortion. So let's have a quadratic lens curvature, and we'll just reduce this a little bit. And we can produce pincushion and barrel distortion really easily. We go the other way, we get it going that way. We probably want to keep this quite subtle, but it just adds that extra touch of realism. We can also add chromatic aberration, although I have to say that I don't think this is working particularly well yet. It takes a while to converge, and when it does, it tends to produce unusual color casts in the render. Chromatic aberration, in case you're not familiar with the term, is the tendency of real-world lenses to not focus all the colors of light at the same point on the sensor or film, so that particularly out towards the edges of the the image, you'll start to get bands of different colors. It's particularly visible if you look at a photograph of something like tree branches against a bright sky. So we can tint the lens slightly if we want to, or quite a lot. I guess this might be useful for simulating a kind of vintage lens that's maybe got a little bit of a color cast to it. We can even use a texture map for tinting it, and we can vignette the lens. I'll just turn off the aberration. So vignetting is where the lens does not produce a uniform coverage across the whole sensor or film back, so that you'll start to get darkening out towards the edges. So that's quite an extreme setting, but that's a little bit more realistic. Then we can tilt our lens, which will change the focal plane, the angle of the focal plane relative to the film. Then we can use Shift to shift the virtual film back relative to the lens. And then we can assign a texture map to the f-stop, so we can define a different f-stop per pixel if we want to, which is pretty crazy. And the focal distance, we can use a texture map to define that as well. So we can produce really sort of quite complex lens behavior. And then finally, we can do things like simulate a rolling shutter. So this is where on particularly cheap digital sensors, the image is read line by line off the sensor, and that can take an appreciable amount of time from the top to the bottom. So it tends to produce a slightly staggered effect. It probably won't be very visible on something like this, but if the camera happened to be panning quickly, you'd really notice a kind of shearing effect. Also notice that we have the same shutter curve controls that we had in Mantra, except here it's on the camera, which kind of makes a lot of sense. You would expect these sorts of things to be on the camera. So we can add shutter inefficiency just by shaping this curve a little bit. And that concludes it for my tour of cameras and lenses in LOPS. I hope you've enjoyed this quick introduction to LOPS and Karma. It's obviously very new. There are a few things that aren't quite working as well as they should. And I've really only just scratched the surface. There's a lot more under the hood in terms of USD, which I encourage you to check out.